Okay, now I'm going to explain section 6, Avogadro's number, the mole, and section 7, molar mass, but just up to page 128. Now we're going to take one step further, speaking about masses. You think that the UMA is a good unit when we want to measure masses in the lab? Of course not, because it is a very, very small unit. Imagine that you want to measure the length of a football field in millimeters. You can, but you will go mad because it is a very, very small unit. So happens with the mass of the atom. Scientists invented a new unit in order to express the atom mass in grams. So we want to change from UMA, which is very small, to grams. Okay? But they wanted an easy relationship between UMA and grams. So they thought, what if we take as many atoms of one element as we need to have the same number for the atomic mass in UMAs, but in grams? Imagine, if this is a beryllium atom, which its atomic mass is 9 UMA, how many of these do I have to put on a scale? Imagine a scale. How many of these do I have to put on it until I have here 9 grams? Well, the number of particles I have to put there, the number of atoms, is 6.022 times 10 to 23 atoms. What if I do the same with nitrogen, which its mass is 14 UMA? How many of these do I have to put on the scale to have 14 grams? Well, the number of atoms is 6.022 times 10 to 23 atoms. So it happens with all the atoms. This is called Avogadro's number. It's always the same number. Okay? And this amount of particles is called 1 mole. In both cases, in all the cases. Okay? So 1 mole of a substance contains always 6.022 times 10 to 23 particles. Why do I write particles? Because it could be atoms, and it could be also molecules. Imagine the molecule of water. Okay, what's the molecular mass for water? Is 18 UMA. Well, if I put together 6.022 times 10 to 23 molecules, 1 mole, I have 18 grams, same as we have explained. So we call these numbers molar mass. The molar mass for beryllium is 9 grams. The molar mass for nitrogen is 14 grams. The molar mass for water is 18 grams. So, what is the difference between relative atomic mass, and molar mass? The number is the same, but we have to put different units for each one of these different concepts. In case that we are speaking about atoms, imagine helium, relative atomic mass for helium is 4, without units because it's relative. Atomic mass for helium is 4 UMA. So as I don't write relative, I use the unit UMA. The molar mass of helium is 4 grams. How is it possible? Because I have joined 6.022 times 10 to 23 atoms, so it's a big amount of atoms. Altogether, weight 4 grams. Ammonia, relative molecular mass. Now, I don't write atomic because now it's a molecule, it's not just an atom. Molecular mass is 17. Without units, because it's relative, molecular mass is 17 UMA, and the molar mass is 17 grams. I have changed it from UMAS to grams, but I have to join a lot of particles, 1 mole in fact, together to have grams.